I myself tell them to pull a calculator out, and they have to do like 2 to the 0 or 100 to the 0, and I always make them do 37.35 or some ugly thing to the 0, and they still get a 1. And I think that visual helps, but I think the place value really helps them.
So one, if I'm summarizing here correctly, for both of these, you're saying, well, if you write all that out and you do your canceling, now they all look like just ugly X's, but you get a 1. And you say, well, on the other side, this is really an X to the 3 minus 3. Right, so over here, this is X to the 0. Right, and you're saying it's even, I think if I'm understanding correctly, you're saying,
place value. I know that 10 to the 0 is my one place, and then I can build it. 10 to the minus 1, 10 to the first, etc. And we do place value a lot in my classroom, so that's just another slide into another way of understanding it.
So when you start writing 321, for example, this is 3 times 100, plus this is 2 times 10, plus this is really 1 times 10 to the 0, right?
But I wouldn't write 100, I would write 10 squared and 10 to the first.
Yes.
So that they see the pattern.
Lots of different ways, I guess, depending on which learners you're thinking about.
Yeah. That's nice for scientific notation, the 321 to the 3 to 10. And it's nice for the kind of -3 squared kind of coefficient problems we were talking about earlier. They're all analogous in that sense.
Oh yeah, I haven't thought about that. Okay, so anything else you guys want to share over here? Because I feel like we were giving this table lots and lots of time. So if not, we'll go on to the third one because I think Jen should be.
You can keep going and save mine to the next time.
Alright, so take a look at this guy. This is another one out of the book, and I put the page numbers up there so that if you want to look, you can see the actual student work. Mine's all typed up because I was doing it last minute. It's in the parentheses and you just do them. And I think usually in the book here, unlike student work, the book is pretty consistent about the error. So if you see, a few of them, he'll give you A, B, C, and D or something like that. They're all pretty much the same error. I think Rich's example, his last example, was that the students are not quite as consistent with their errors. It might be a little bit harder to spot them. We've all graded papers and said, well, at least they're consistent with it, right? They're always doing this exact same thing. So can you guess what C and D are going to be based on what is?
Would you keep?
You're
right.
So
You're right.
they're going to do 3x in here. It's kind of surprising. I know.
Did you check your answer on your phone?
I ran out of space there to go left, right. Anyway, so how do you deal with this one? What do you say? Do we all just say like terms versus unlike terms?
That's a major misunderstanding there. I'd be with you in meeting notes down to the tiles to see the difference between them.
A simple interview works too. Why'd you do that? And, sometimes it's not the answer you expect.
I grab 2 calculators and 5 pencils and I say, got 'em. Well, I can't. That's the point. after I do a physical in the classroom.
But if you ask them before you do that, you might hear, well, I had to do the parentheses first.
Right,
And then they're just forcing the addition. So we want to know why they did the addition, not just that they did it. They might even have a sense that they weren't supposed to do it. But you want to figure out why they did it. And the only way to do that can't be done without asking them. And sometimes we don't have that luxury, sometimes we do.
So if they didn't know what else to do the parentheses, they're like, well, I'll just add because then I know how to do everything else.
Because they don't do the like terms wrong later.
Right.
I mean, they get that they're not in the
Exactly.
parentheses, right?
Yeah.
So
Once
there's
you
no
get-
value to the tiles or the, because that's not the error. The error is if they think something has to be done there. And it's
And
not
maybe it's
distributed.
because it's parentheses, it means multiplication, and it can only multiply when there's one thing inside of it. So if there's two things, I gotta make it one thing to do the multiplication.
And none of that we can get from reading the paper, I guess is my point. I mean, that's the point where, at least for me, my life becomes very difficult because I can't just go up to the student and find them, not in a college environment. They're gone by the time I'm grading.
Yeah. And then what do you write on their paper? And then how much do you hope they actually read what you actually wrote on their paper later after they do that? See, it's the same everywhere. Okay, so I'm done. Fung Jin is going to talk to you now. Thank you.